Okay, bit more progress. I've got the output from the Arduino going through a resistor to the LED so that the LED switches on. We saw that before. It also goes through a 330 ohm resistor into the base of this power transistor. It's about a 5 watt. I think it's a 5 watt transistor, 5 amp, sorry, 5 amp at 500 volts. It'd need a big heatsink if you're going to use it to its optimum ability, but it can handle a high voltage across its collector and emitter without frying. So I could use that transistor to switch the solar voltage to something if I wanted to. So that's why I bought that one. I could have got a cheaper one, but that one was only $1.70 or something like that. Rambling away. Got a flyback diode across the inductor, which is the relay, and then when the conditions are met to switch that, you're not going to be able to see anything. You'll probably hear it more than anything. When I set the conditions for compressor to switch on, you can hear, we'll be quieter this time. So you can hear it switch off. Switch on. Switch off. So what would you say, the on current for the transistor is about 0.2 amps at 19 volts. I'm using a charger off a laptop to give us some simulated battery power, if you like. It doesn't need to switch that much voltage. I'm confident that it'll still work fine on 12 to 14.2 volts or 14.5 volts. I think my battery bank charges to when it's on bulk charge, and I'm really stoked at that. So now I need to figure out the logic for my switching algorithm in the Arduino. So I've done up a flow diagram, and I don't expect you to be able to read that, but there are a lot of conditions I want to take into account when the thing switches on. So if the compressor's on, it'll check to see if the battery's high and the solar's low. If that's true, then it'll switch off the compressor. If the voltage is of the battery's low and the solar's high, it'll switch off the compressor. If the battery's lower than a certain amount and the solar's lower than a certain amount, it'll switch off as well. But all these amounts are different, so I've got to code those in. If none of these conditions are met, in other words, the battery voltage and the solar voltage are above a threshold, then it'll stay switched on. I haven't drawn a no thing to back to the top, if you know what I mean. It's not a good logic diagram. This side of it I've sort of drawn a bit better for that sort of thing, because this side was a bit too busy to do it with. So if the compressor's not on, it checks if the solar's high enough. If it is, it checks to see if the battery's high enough. If it is, it turns on the compressor. It waits. It checks every 3 seconds to see if the battery voltage drops below a certain amount, which I've written here as 11.5. I think any lower than that, and we might have a stalled compressor. But I can simulate that out on the boat to check to see if that's right. All I need to do is unplug the start capacitor on the compressor, and it won't start. It'll just be stalled. And after a fair bit of time, the over temperature on the compressor will disconnect the compressor. So if this fails, it's not critical. It's just better if we don't waste the compressor and the battery. So when it turns on, we want it to wait 5 minutes before it goes back to the checking routine, so that the compressor and the batteries and the solar have got time to stabilize before it switches the compressor off. If these conditions aren't met, it'll switch the compressor off, and 5 minutes of running the compressor won't run down the battery bank enough to cause any damage. So once it's happy that it's running, it'll ask itself again, is the compressor on? Yes, and it'll go through this side of things. If the solar's not high enough, I want the Arduino to go to sleep. I haven't mastered that yet, but from what I can tell, that is a doable thing with the Arduino. I'm not sure if I'll get there yet. The amount of power consumption the Arduino has when it's just running as it is there is fairly minimal, but in sleep mode it's a lot less. So when there's no solar, I would like it if this thing used the minimum amount of power. If the battery's high enough, if the battery's not high enough but the solar is, I'll probably put a little delay in there, but it can just go back and around and just keep polling that. And once the solar has charged the batteries up high enough, then it can switch on the compressor, because I don't really want it to run the compressor without the house batteries already charged up. The compressor draws about 8 amps. The solar array can provide about 15 or 25 or something, but I don't really want to put the system under any more strain than needed. The difference between having solar power and not a charged battery, and solar power and having a charged battery, really is only maybe an hour in the morning, depending on how much you run the lights and the radio and other stuff on the yacht when the solar isn't running at night. So just got to implement this piece of smoke and mirrors and software, and it's certainly a challenging thing, and so far it's been pretty rewarding. I'm very happy with the way it's going.